All right, guys, next up we got piecewise functions. I know you guys did these a lot last year. They tended to be, sometimes people get them, but for some people they just never click. All right, so I'm gonna walk you guys through one just for a little bit and see how it goes. Remind you guys how to do it, okay? Graphing is the hard part about it, well, harder. But just remember for graphing piecewise functions, or for just evaluating piecewise functions, right? Like the first couple questions are going to be like, what's f of -4? What's f of 0, right? So remember for those, if I'm plugging in -4, just make sure you find the domain that it fits into. Okay, so remember for piecewise functions, there are different functions in different domains. It's split. They call it a piecewise function because there are different pieces. So like in this one, for any value of x that's less than 3, that's the -3, sorry, the value of the function is 2, right? So since x is, if we're plugging in a -4, it fits into that top domain up here because that's less than -3, so that's just 2, right? 0. Well, what domain, which piece's domain does that fit into? Well, 0 is between -3 and 1, so we're fitting into this domain, right? Which means that the value of the function is x. So if x is 0, that means our function is 0, right? Now you have to keep that thought in mind as you're graphing to remember that there are 3 different pieces to this graph. It's not like 3 lines all on the same graph that all extending on forever, right? Remember this 2 only exists when x is less than -3, okay? And just remember that these are equations, they're lines, they're graphs, right? So think of it this way, right? You can split it up into different parts and just look at it like this. Think of it like a regular graph. This is y equals 2, okay? So if you have that first thing, if it's just y equals 2, right? Well, you guys know what y equals 2 looks like. That's just a horizontal constant line. But remember, it starts or stops, however you want to look at it, at -3. It only exists when x is less than -3. So it's going this way, right? And notice I put an open circle because it's just less than, not less than or equal to, right? Now you go to the middle one. That's y equals x, okay? Now this graph doesn't start until -3, okay? So how you guys can do this if you want to, there's a lot of different ways people do this. Like some people like to just plot it like a regular y equals mx plus b, like you plot the intercept and then you can use your slope. Just make sure you don't go past -3 or 1, so you can do it that way if you want. A lot of times what I like to do is just use your boundaries, right? So remember, -3 is a boundary because to the left of -3, your value is 2. To the right of -3, your value is x. So this is where you stopped technically, right? Because the 2 stopped at -3. So plug in a -3. If x is -3, y is -3. So we're gonna put a coordinate point there. Okay, now notice I used a closed circle because it was that. Okay, and then just use your slope. Your slope is 1, right? So you're going up 1 over 1, up 1 over 1, up 1 over 1, and you're going to stop at 1. Okay? Your next one, you're using the graph of y equals 1/2 x minus 3. Okay? So again, start with your boundary point. Right? Plug in a 1. 1/2 times 1 is 1/2 minus -3 is -2.5. Right? So we're going to go to 1, -2.5, and we're going to put an open circle, right? Because it's greater than 1. Okay? And then use your slope. Right? You're going up 1 over 2. Up 1 over 2. Oops, I only went over 1 because I can't read a graph right. Up 1 over 2, up 1 over 2, up 1 over 2, okay? You don't have to be, you only have to make a couple dots, just make sure it goes the right direction, okay? And there you go. All right, and that is graphing a piecewise function. Now remember, because it's a function, it should pass the vertical line test. So you should be able to draw a vertical line anywhere on this graph to know that, and it's only going to pass through one time. Okay, that's why these need to be open, closed, closed, open, or both open, right? They both can't be closed because that would be two. If this was closed, then you'd have two y values with the same x value of 1. And remember, that can't happen. The function has that one-to-one notation where each x value can only have one y value. Okay, so do that vertical line test when you're done graphing as a quick check. All right.